Okay, guys, so now we are on to part 2 of the solving exponential equations. So one of the key things is we are definitely going to need a calculator, and you're going to need a calculator with logs on it, okay? So we want to round our answer to 3 decimal places. This is at the end. Okay, so we're not rounding to 3 decimal places while we're working. We're only rounding to 3 decimal places at the end. Okay, so we don't want to round too soon. All right, so last time what we did is we said, all right, can I rewrite the equation so that they have the same base? So now when I look at this equation, I say 11 is my base. Could I rewrite 32 as 11 raised to something? No. Is there a way that I can rewrite both sides with the same base? No. Okay, so this is the case where we have to solve using another way. So we're going to kind of rewind back to what we tied in with the inverses of each other. So we switched from exponential to logarithmic form, and from logarithmic to exponential form. So we are going to use logs to solve these exponential equations, just like we used exponential equations to solve then the log equations. So we kind of switched it to exponential form when we had logs. Now we're going to switch it to logs. So what we're going to do to solve this is whenever you can't rewrite it, you're going to use the word log. So what we're going to do is we're going to log both sides. So I'm going to take log of this left-hand side, and I'm going to take the log of this right-hand side. And one of our properties of logs say I can take this exponent and boop, pop that down right in front. So I'm going to rewrite this as x log of 11 equals log of 32. Okay, so now what I want to do is I want to solve for x. So because this x is being multiplied by log 11, I'm going to divide both sides by log 11. So the log 11s are going to cancel out, and we're going to get x equals. Okay, so now this is the part where you have to be kind of careful in your calculator. Depending on which type of calculator you have, you might have to do the steps a little bit differently. So you might have to play around with the calculator until you get the matching answer. So in my calculator, I'm going to do log 32, and because it had an open parenthesis, I'm going to have to close the parenthesis after that 32, divided by, and then I'm going to hit the word log 11. And I'm going to close that parenthesis, and I'm going to hit enter. And my answer is 1.44. And then it goes 5.3, so it's 5. All right, so that is my final answer for this one. Okay, so for the next one, we're going to do the same thing because we can't rewrite it. So I'm going to use the word log. So I log the left-hand side and log the right-hand side, and I take this exponent and I'm going to bop that down in front using that properties of logs. So it's going to be x log of 6 equals log of 8. And now I want to solve for x, so I want to divide both sides by what's connected to the x, which is log of 6. All right, and then the logs of 6's cancel out on the left side, so we're left with x all by itself equals log of 8 divided by log of 6. So I'm going to do log of 8, close that parenthesis, divided by log of 6, close that parenthesis, and hit enter on my calculator. And I get 1.16. Now just to kind of write off to the side what it is, it's 1.160558. 0558. Okay, so and then it keeps going in my calculator, but this is just for example purposes. So I want to round to 3 decimal places. So I look at this one and I say, since it's a 5, this 0 gets rounded up to a 1. Yeah. All right, so that is my answer for number 2. All right, now for number 3, we have an E. That's a special one. So because it's a special one, we're going to use the one that ties in with E, the special one. So that is, instead of using the word log, we're going to use the natural log, ln. So we're going to do ln. And then we're going to take that exponent and bump that down. So we're going to have x ln E equals ln of 51. Now here's this nice cool thing about ln and E. ln and E are kind of like the square root and squared. They're inverses of each other, so they cancel out. So when you have ln and E, they're inverses of each other, so they cancel each other out when they're right next to each other, and it just becomes 1, and 1 times x is just x. So we have x equals ln of 51. So now we have to do x equals, and now I have to find the ln button, ln of 51. So this one we don't actually have to divide by because the ln and the e are canceling each other out. So that's kind of cool for that one. So we've got 3.9318, so 932. And then we box that in. All right, so now on to the next one. We're gonna, since it's only that base and the exponent, we're gonna log both sides. And we're gonna take this exponent, which is more than just plain old x, and we're gonna bop that down in front. So I'm gonna do x minus 1. I'm gonna just put that in parentheses because it's more than just plain old x. Log of 19 equals log of 41.7. All right, and now when I want to solve, I'm going to divide both sides by, get rid of that log of 19 that's connected to the x side. So these cancel, and I get x minus 1 equals, now I'm going to type this into my calculator. So log of 41.7, close that parenthesis, divided by log of 19, close that parenthesis, and I get 1.26696. Remember, I'm keeping this, I'm not rounding until the end. So I add 1 plus 1 plus 1. So in my calculator, I just hit plus 1. So I get x equals 1.3 decimal places, 2, 6, and instead of a 6, we round up 1 to 7. All right. Okay, on to the next. So we've got 10 and 100. Ooh, could we rewrite them as the same base? Yeah, we could. 10 to the 5x, 100 is 10 squared. So do I need logs for this? No, we could do this just like part 1. And I cancel those out, boom. 5x equals 2. Divide by 5. X equals 2/5. Now, could I have done this using logs? Yes, I could. But I wanted to show you guys just a reminder about how if you can rewrite it, it's a lot faster. You don't need to even use your calculator on that. All right, number 6, we've got, our special one, E. So we're going to use our special log, which is the natural log, ln. We're going to take that exponent and bump it on down. So negative 2x ln E equals ln of 62. Now remember, when you have ln and e right next to each other, those are inverses, so they cancel each other out and just become 1. So negative 2x times 1 is just negative 2x equals ln of 62. All right, so now we're going to do ln of 62. And that becomes negative 2x equals 4.12713. Remember, we're not rounding until the end. Last step, divide by negative 2. Divide by negative 2. So in my calculator, I'm going to divide by negative 2. And I get x equals 3 dp's, 3 decimal places, negative 2.064. Okay, because it was 0.635, so we round up to 0.64. All right, so I'm going to pause right here for a second, and we are going to then do the second half.